So now we'll study the database security. And what is the database security and what are databases? Databases are used to kind of store the data on the internet. So the database security refers to protecting the databases from unauthorized access, corruption, theft, and other cyber threats. And the three goals of database security is CIA triad, confidentiality, integrity, and availability. And these are common threats and their protections that we can do for the database security. We have SQL injection. We have talked about this in the previous one, that attackers inject malicious SQL queries to manipulate the database. For example, for this query, you suppose and see, can you guess what is, what is, the thing here which is really bad about this one, which can cause the malicious. We are saying select from users where username is this and password is this one, right? Now you can see that user is admin and password is nothing, right? But this is the point here, right? So we only know that the username for admin would be admin, but the password is, we don't know it, right? And we don't know really the password, so the attacker route, the username is admin, and then it commented out in SQL. We use two kind of, these dashes to kind of comment out things. So effectively, the query we done here, right? Apparently the query is going to check that select from the users where the username is admin and password is this one. Empty means the attacker didn't know the password and he just wrote it as empty. Otherwise the admin has some password, right? Now, but because it commented out this one, this line will be really, considered as a comment, and so it will only check select from the users where username is admin, effectively getting the data of the admin, right? So that's how it's injection type, because we're really writing the malicious SQL queries to kind of get the data. And we may not really know it, but there are little changes and tweaks in the code that they do to kind of attack your system. So protection strategies use prepared systems like parameterized queries. Instead of saying this where username is admin, you should have a keyword where you should use this placeholder, and then you should pass your username as the parameterized, right? So you should use placeholder in terms of the real element so that the attacker cannot easily access it, right? Sanitize user input, escape the special characters like these ones. Implement web application firewalls, right? Real example, 2018 British Airways hack. SQL injection was used to steal 380,000 customer records in 2018 in British Airways hack, right? Privilege escalation and unauthorized access. Threat. Attackers gain higher-level access than intended. A user with read-only access discovers a flow that allows them to delete the records, right? So we are using the internet, but we're not really saying the things in the real, law form, but there are people who kind of see it and go through these things. And even if you really learn about this, then you will get to know them. So they maybe they have only the read-only access, but they discover a flaw that they can write data or they can kind of delete the data. So the privilege escalation and unauthorized access can be protected by rule-based access control. Assign permissions based on rules, least privilege principle, users get only the access they need, right? So these are a bit different. Enable multi-factor authentication for database admins, right? Especially database admins, because they try to kind of manipulate the admins, because admins have kind of the whole power here. Give example, Capital One data breach 2019, a misconfigured access control followed an attacker to streak 100 million customer records in 2019 on the Capital One data breach. Okay, insider threats, employers or contractors misuse the legitimate access. Rather, a disgruntled database admin sells customer data on the dark web. Really important. Protective strategies, database activity monitoring, and that's why I think there was this concept or principle of the system user design we have studied that asked us that we should work in teams and not alone. I think it was, let me check. It was basically separation of duties, right? The separation of duties principle that we studied in the system. Oh, sorry, I think it was security design principle, right? So you should have a database activity monitoring that if one person is doing bad, you should see and look at the other person. So this is basically database activity monitoring, DAM, track and log database activities, encrypt sensitive data. Even insiders can't misuse stolen encrypted data. Even the stolen data should also be encrypted so that you can't misuse it. Regular security audits and access reviews. Of course, these are all the organizational things. Tesla insider attack 2020. Employee tried to sabotage Tesla's database, but was caught due to monitoring systems in 2020. Data leakage and poor encryption. Sensitive data is exposed due to weak encryption or misconfigurations. Right? Here we have, misconfigurations that there's a probability that our data could be exposed, like a database backup is stored in an unprotected S3 bucket and accessed by attackers. Usually the backups should also be stored in security. For example, protection strategies use strong encryption like AES-256-DD for data at rest and in transit. The data we are using and the data we are storing should also be protected. Mask sensitive information, social security numbers, and credit cards unless you're using them or you are given permitted. You should mask these both. Secure backups and store them encrypted. You have secure backups and also store them as encrypted so that attackers still can't be able to have these as well. So these are protection strategies. We should have strong encryption, we should have mask sensitive information and secure backups. Facebook password leak 2019. User passwords were stored in plain text and exposed to employees. Right, passwords were exposed to employees, meaning employees can also gain unauthorized access, right? Denial of service attacks on databases. Attackers flood the database with queries, causing downtime. A botnet sent millions of fake database requests to overload the system. Implement a rate limiting and query throttling, prevent abuse, right? So rate limiting means how much the database could handle, and query throttling means the kind of searching the query is it really what the system is intended to have. Use load balancers and replication for high availability. Load balancers means there are more extra systems and replication for you to, so you can always make your database available, monitor and block suspicious traffic using intrusion detection system. A more common is this one. This one is expensive and this one is also used. Rate limiting and query throttling. And then real example, GitHub DDoS attack. A massive traffic surge temporarily crashed the database servers for GitHub. Database security in the modern world, zero trust database architecture, AI-powered anomaly detection, AI tools not unusual databases access patterns, secure cloud databases, services like AWS, RDS, and Google Cloud SQL implement built-in security layers. Because of these DDoS attacks and the really need of implementing these securities, now we have security layers as well. Database system, access control, RBAC and MFA means we should have role-based access control, and we have multi-factor authentication, encryption, monitoring logs, AI detection, backup, and disaster recovery. Alright, so this was database security, and we have kind of studied kind of threats that can occur in databases. We have SQL injection, we have privilege escalation and unauthorized access, we have the insider threats, data leakage, and poor encryption. And then we have denial of service attacks, right? And poor encryption, we talked about that if we have a weak encryption or we have a misconfiguration, right? Misconfiguration that like this, that passwords are stored in plain text and exposed to employees, right? So in the next one, we will study about the firewalls.